quotients of rational expressions. So what we did yesterday was looking at rational expressions and rational algebraic expressions. Okay, so today we're just adding that second element of taking two of them and either finding their product, meaning multiply them, or taking two expressions and getting their quotient. So quotient means to divide. Okay, so let's start with the super easy, like, bless you, Algebra 1 level problem. So if we have 6xy over a squared divided by 3y over a to the third x. Okay, this is sort of a Algebra 1 level. We don't have any factoring in it quite yet. We're going to get to that in the next two. But there is division. Okay, so there's a trick or a rule that you use when you're dividing two fractions. Anybody know it? Yes, it's called invert and multiply rule, right? So you're going to rewrite the first expression, 6xy over a squared. Then you're going to change it from division to multiplication. And you're going to take the second one and you're going to invert it or flip it. So it's going to become a to the third x over 3y. Okay? And think of this as a fraction times a fraction. So when you reduce, which ways can you reduce or which ways can you not reduce? Diagonally or up and down, okay? But not straight across, okay? So let's see. I'm seeing a 3 and a 6, right? So they're both divisible by 3. 3 goes into 3 once, 3 goes into 6 twice. And then I'm also seeing a y to the first and a y to the first, so gone, gone. Then I'm seeing an a to the second and an a to the third, so the a to the second's gone, the a to the third becomes a. And then all that's left is x's, and they're both in the numerator. So we're going to multiply what's left straight across. So in the numerator, I've got the 2, the a, and the x to the first and the x to the first. So 2a x squared. In the denominator, all that's left is a 1. Do I need to write the 1 in the denominator? No. Would it be wrong if you did? No. All right, so all we're left with is 2ax squared. Any questions on example number 1? Bless you. All right, example number 2 is a more of an Algebra 2 level problem. Okay, so we're going to start with 3x squared minus 6x over x squared minus 6x plus 9 times the x squared minus 6 over x squared minus 4. All right. So this is kind of getting into what we did yesterday, right? Where you can't just go, oh, there's an x squared and there's an x squared, and then cross them off. You can't do that with terms. You can only do that with factors. All right, so you need to know the difference between terms and factors. Terms have pluses or minuses between them, and then the factors are just going to be right next to each other, indicating multiplication, okay? So you're going to want to factor just like we did in chapter 4, using all those techniques we learned, always starting with, is there a greatest common factor, right? Then look for patterns. Patterns can be shortcuts for you, right? Or seeing if it's one of the easy ones, or do you need to do slip and slide, okay? So let's start with the expression on the left. We've got 3x squared minus 6x. I see a GCF. What is it? 3x. Okay? So if we factor out a 3x, that leaves us with an x minus, not 6, 2. Okay? Now let's check out the denominator. Is there a GCF? No GCF? How about a special pattern? Yes, perfect square and perfect square, right? So this is going to factor to square root of x squared, which is x and x. Square root of 9, which is 3 and 3. And because this middle term is negative, that means it's x minus 3 and x minus 3. Okay? Now let's jump up to this numerator. No GCF, right? How about special pattern? Not a special pattern, but it looks like an easy one, right? Because it has a coefficient of 1. So we're going to take the square root of x squared, which is x and x. And then what two numbers are going to multiply to get negative 6, but add or subtract to get negative 1?
2 and negative 3.
So plus 2 minus 3. Okay? And now let's factor that denominator. No GCF, but definitely a special pattern, right? Easiest way to know it is because it's only 2 terms, right? So that's the one where you take the square root of each. Square root of x squared is x and x. Square root of 4 is 2 and 2. And your signs are what and what? Plus minus. Okay? Once you've completely factored everything, at this point, if there's canceling, cancel away, right? I see an x minus 2 and an x minus 2. Gone. That pen sign. Let's try it with red. There we go. I see an x plus 2 and an x plus 2. And then an x minus 3 and an x minus 3. All right. In the numerator, all we have left is that 3x. In the denominator, that x minus 3. If you wanted to put it in parentheses, you can, but you don't have to. And that's as far as we can go. All right, any questions on example 2? All right, example number 3. I'm going to put a fraction within a fraction. So we're going to have like a double quotient. Okay, so here we go. A squared minus 4ab plus 3b squared over a plus 2b divided by a squared minus ab minus 6b squared. We've got a fraction within a fraction. And sometimes you'll even see a second denominator. I'm going to actually just write one. I'm going to write a denominator of 1. So this is actually the first expression being divided by the second expression. Okay? So if you were to write this out, you would say this one, so the a squared minus 4ab plus 3b squared over a plus 2b being divided by this one, a squared minus ab minus 6b squared over 1. Okay. Then you have to do the invert and multiply rule on it. Okay. We're showing this step in the notes, but in reality, when you come to doing it on your assignment, you could probably skip this step and go straight to the, okay, I know this one's going to stay, and then I change this to multiply and flip this, right? So it's 1 over a squared minus ab minus 6b squared. The first one stays, right? If when you're doing the assignment, if you want to skip this step, that's probably doable, like most of your brains can handle that, right? Okay. Now we want to factor. Okay. So let's start with this first numerator, the a squared minus 4ab plus 3b squared. So to get a squared, we're going to multiply a times a. And then we've also got a b squared. So we know there's going to be a b and a b. But then the rest of it's one of the easy ones, right? What two numbers multiply to get positive 3, but add or subtract to get negative 4? Minus 1 and minus 3. You don't even really need to write that 1. It just helps you keep track of it, right? Okay. How about that denominator, a plus 2b? Is there a GCF? No. Is there even a square in there? No. Is it possible that it's completely factored? Yeah. Okay. All right, in the numerator over here we got a 1, that's easy. Now let's look at this denominator. Okay. So let's factor this. Square root of a squared is a and a. Square root of b squared is b and b. And then the rest of it is the easy, right? So what's going to multiply to get negative 6, but add or subtract to get negative 1? Minus 3 and plus 2, yes. Minus 3 plus 2. Okay. Once you have it completely factored, you look for what you can cancel. All right, I see the a minus 3b and the a minus 3b. Can I cancel the a plus 2b and the a plus 2b? No, because they're across from each other. Okay, so we actually have a more left than we did on the other one. So in the numerator, we have the a minus b. And in the denominator, we have 2 of these, right? So I'm just going to say a plus 2b and then s squared. Okay? If you wanted to write that a plus 2b times a